what is the source of causality, right? It comes from all over the place. In my own kind of past work, I've been building models. I've been, cleaning and engineering data. I've been also designing algorithms. And we also later on built software systems and user interfaces, all that, right? I think, if you are looking at any kind of outcome and ask for causality, they actually exist in all these dimensions. So my own take is that there are something that we cannot control, which is the God, like the world, the universe, that where the data come from, or in a reinforced setting, the environment is something we cannot control. But what are the things we can control? Well, the model we built, the algorithm we design, the system we implement, and the interface that we also present. These are the things we can control. So I think this is a natural boundary already. Within the things we control, I would say we would like to introduce as little as complexity and uncertainty as possible, right? We don't add basically to the trouble, in our implementation, which is actually not very well, recognized. You can see how many people have no problem, building yet another bigger model of which you don't know what's going on inside, or introduce a approximation algorithm that you don't have control about, the convergence, or the speed, and also maybe a very big software system which has millions of lines of code that is completely undebuggable. I would say that the first boundary is the nature and also a man-made system. That within the man-made system, what we can do to optimize our own conduct and practice, and then we mitigate the uncertainty from the nature. If you fly an aircraft, your design absorbs many of the aerodynamic kind of behaviors, the turbulence, the temperature, the other things, the ground condition. You already try to absorb that through all possible imaginations. And right now, I actually don't think this is the common practice, at least in machine learning and AI. Okay, it is actually a common practice in mechanical engineering, in electricity and other things. But in machine learning and AI, look at how many proofs we do by assuming the nature is naive, by actually limiting the condition of that, right? It's not about really mitigating the uncertainty in the nature through our system, but to really, let our system or our imagination fly by limiting the nature. That's actually what I see to be the biggest problem. So I would say, define the boundary in first of all, a very humble way to say that, we do our job, the best as possible and the simplest possible to get work done, and also understand what we do. And that's where I see causality, causal inference be very, very valuable, because causal models are among the not too many existing AI machine models, which actually invites people to look into it and also to, conduct, inference, reasoning, and dissection, and also proving, unlike many of the other models we use, but not actually exploring that complexity.